Today we are going to build end-to-end data engineering project using Databricks. Databricks is gaining a lot of popularity and we will use this platform to build a project in FMCG domain that you can add directly to your resume. In terms of technical stack, we will be using Python, SQL, S3, Medallion architecture, Databricks dashboard and Genie. We will be doing all of this in Databricks free edition. Yes, it is completely free. It doesn't even ask you for your credit card. This edition enables students and practitioners to learn data and AI tools for free. For people who don't know about Databricks, it's a leading AI and data platform for enterprises. The reason for its popularity is its ability to simplify their architecture and speed things up at the same time. It has helped many companies like HSBC to perform analytics at scale while keeping it secure. Alright, let's look at the problem statement for this project. Atlicon is one of the leading manufacturers of sports equipment operating across several countries. For years, their operations ran on mature, ERP-driven systems, predictable, structured, and reliable. Recently, Atlicon acquired Sports Bar, a fast-growing startup in the energy bars and athletic nutrition space. But unlike Atlicon, Sports Bar's data is everywhere. Spreadsheets, cloud drives, WhatsApp exports, and hastily built APIs. Atlicon's leadership decided to retain Sports Bar's culture, teams, and processes. A respectful but risky choice. And soon, the consequences became clear. Their data formats didn't match. Their reporting cycles didn't align. And some months of Sports Bar's data simply did not exist, lost during their hyper-growth phase. As Atlicon prepared to unify supply chain, forecasting, and inventory planning across both companies, the data chaos became a bottleneck. Metrics were inconsistent, sales number conflicted, nothing tied together. That is when Bruce, the seasoned COO known for solving operational puzzles, stepped in. He approached the data engineering team, led by Tony Sharma and driven by curious Peter Pandey, the data engineer. Bruce's request was simple but daunting. Give us a reliable data layer for both companies, something we can use until we fix this mess. And that sets the stage for this Databricks journey, where Tony and Peter team must tame messy formats, align metrics, fix missing data, and build a scalable foundation for a newly merged giant. Together with Tony, Peter, and Bruce, you will be solving this problem using Databricks free edition. Get ready, folks. Tony, I saw the email from Bruce. Looks like we have a very short deadline.
Welcome to the world of data chaos, Peter. I know this was gonna come, but not this soon.
Well, but the good news is team at Sports Bar is very supportive. Some of their data engineers know Databricks already. So we can do this, I guess.
You guess? No more guessing, Peter. We need to do this. Let me tell you, there are 3 success criteria for this project. Number 1, you should be able to provide the aggregated analytics of both these companies in one single dashboard. And the most important thing, the solution should be reliable. Number 2, the learning curve should not be very steep. Let's say we are going to hire a bunch of data people who can work on this tool. I don't want that to be very difficult for them to learn. And number 3, this is also a very important thing. See if this can be a long-term solution. I mean, it should be scalable. Why I'm saying is that we can't trust, right? Now they're saying they will change the systems of Sports Bar in a year. But what if it takes more than 1 year? What if it takes 2 years, 3 years? We should have a solution that is quite scalable. So see if this can be a scalable solution. Okay, does it sound clear to you?
Yes, Tony, it's super clear. I'm excited to begin work on this project.
Great.
Before we begin the actual project work, let me clarify something. You need to know Databricks Foundation for this project. If you don't know it already, I have another video that you can watch. I'm going to provide you a link. And if you know the Databricks Foundation, then you can just continue further. We already saw in the problem statement that Atlicon is a manufacturer of sports equipment such as cricket bat, badminton racket, volleyball, and so on. And it's a big company which has acquired this small company called Sports Bar, which makes energy bar and athletic nutrition products such as this bar and sports drinks and so on. Now, Atlicon has an established data infrastructure. So they have OLTP system where they have a proper web application, mobile app. When you go to Atlicon store, you buy, let's say, cricket bat, you will be performing a transaction and all of that data will go into OLTP system. They also have OLAP system, which is your analytical processing, where they use Databricks, and they have bronze, silver and gold layer. Bronze will contain all the data from OLTP, so it's a raw data. In silver layer, you will do data cleaning, you will do currency conversion, some transformation and so on. And in the gold layer, you will generate BI ready columns. So you might generate some additional derived columns based on the raw columns that you have, and you might perform aggregation, etc. Eventually, you use gold layer to build BI dashboards in Databricks. You might also use Genie, which is an AI assistant. Okay, so this is a very nice data infrastructure that Atlicon has, but their problem is this small company that they acquired, they don't have a proper data engineering system. They have OLTP, and directly they are building Excel dashboards by pulling data from the relational database. Let's say if they're using Oracle, from that they will directly build this Excel reports. And the management has decided that they don't want to get onto this multi-year migration project. I mean, they will do it eventually, but in a short term, management wants streamlined insights. So let's say if CEO of Atlic wants to know the revenue from both the products, Atlicon products as well as sports product, they need some single dashboard where they can see it. If they want to see top 5 products, it should aggregate both the products, Atlicon's and sports bars product. So data engineering team came up with this smart solution where you will take OLTP of sports bar and you will dump that data into S3, AWS S3, okay? And then you will build a data pipeline for sports bar. So you will have bronze layer, silver layer, gold layer. You will do all the transformations, okay? And I have this line here which shows that when you're doing daily file processing, when the files are processed, you move it to archive. Okay, so when we do coding, we'll actually see how it works. But the idea is this diagram represents the data pipeline for sports bar, which is a child company. Okay, and once you have gold layer for a child company, you will merge that data with the gold layer of Atlicon, right? For Atlicon also, there is a bronze, silver, and this is a gold, right? So I have not shown this here, but this pipeline is established. So we are not making any changes to it. We are going to be mainly focusing on building the data pipeline for child company. And then we will merge this sports bar gold data with here. So now when you build a dashboard using this gold, you will have the aggregate products information from both sports bar as well as Atlicon. In terms of data timeline, this project will be going live in production on November 30. So you have about 5 months data for sports bar. So when this merger happened, sports bar gave this 5 months data. I mean, in their systems are containing 5 months latest data, and we will be doing historical backfill. So we will be doing essentially batch processing here, okay? So in data engineering, there is batch processing and there is live data processing. So for historical backfill, we'll use this 5 months data from sports bar. And then from November 30 onwards, for December, we will do incremental update. And as far as Atlicon is concerned, as I said, in this project, we are not going to look into the data pipeline of Atlicon, okay? We just assume that Atlicon has a good data till November 30 in their gold layer. And in that gold layer, we will do first. So let's say there is a gold layer, right? So this is a gold layer of Atlicon. So we will first do historical backfill of this 5 years data into here. And then from this point onwards, this gold layer will contain the incremental update from sports bar, okay? All right, so that was the quick overview of technical architecture. Let's now understand the data model, which is nothing but the structure of the data tables and how they are related or linked to each other. We are going to provide you this data folder where we have data for parent company and child company. If you go to parent company, you will find two more folders, full load and data load. Full load contains data till November end. Incremental load contains data for December 2025. Okay. If you go to full load, you will find 4 tables. So there are 3 dimension table and 1 fact table. So let's look at these tables one by one. So the first one is DIM customers. This table is super simple. You have customer code, name of the customer, market, platform, and channel. And if you set up the data filter, see in the channel, you will see direct or retailer. Okay. Then the platform, let's say if Atlicon is selling their product on their website, platform value will be e-commerce. If the item is sold through the store, they have the physical stores as well, then that is brick and mortar. And market wise, we have just one market, India. In the future, if they expand to other countries, they will have another country. Okay. And these are the customers. Now, this particular company, Atlicon, is selling to their other companies, basically other small companies. Okay. So this is like a large manufacturer of sports product. So small sports company which are selling the sports equipment will buy from them. Okay. So it's mostly B2B business. That's why we see only these many customers. So Prime Sports, for example, is a sports store in, let's say, New Delhi, and they will buy from Atlicon. Okay. So I hope you're getting this data model. So this is your customer table. The second table is products. So product table is also pretty straightforward. You have product ID, division, category, product. So let's say if you are searching for a cricket, right? So let's say I am here going to go with cricket bat. So cricket bat. Okay. So cricket bat, that is a category. Division will be cricket. And then there will be actual product name. Okay. And the variant. So usually you get variants, right? See arrows, like you get 12 pack. I think if you look at this data, you will get it, folks. It's pretty straightforward. Then you have gross price. So you see this product code. So same product code is available in the pricing table, and you have price INR and you have year. See, usually in the industry, what you'll see is the pricing will be having 2 columns, effective from and effective to. So the price is valid between these 2 dates because price changes, right, all the time. But just to keep things simple, folks, what we have done is for this particular year, this is the price. Okay. So now if you join this gross price and product table, you will be able to know, okay, how much, let's say, this particular arrow item cost you. At last, you have a fact table. And in fact table, you have a date when the transaction was made. This was a product. This was a customer. So customer number this bought 161 quantity of this product on 1st January 2024. Pretty straightforward, simple table, folks. Pause this video and think about it. This entire data model is extremely simple. And here's a pictorial representation of this data model. It is essentially a star schema because you have this fact table in the middle, and it will form something like a star, right? Like, see, it is forming, sorry for the bad picture, but it is forming this kind of a star. That's why it's called the star schema. And as you can see, customer ID from fact orders is linked to this customer ID in DIM customers. Then this product ID is linked to this 2 tables in DIM products and DIM customers. So if you look at any order and if you want to compute the price of the order, it's easy for you because using the product ID, you can fetch the price, right? And then using the same product ID, you can fetch the quantity. Quantity is here. Okay. And you can also know, okay, what is the product name, category, customer name, city, and so on. There is also data for child company. And in child company, you have full load and incremental load. For incremental load, we have orders from December. Okay. So when we look into incremental update part, we'll look at this order. But if you look at the full load, you have customers table. Now see, customer table looks something like this. So here, customer ID, customer name, city, and like you can just look into it. Like there will be some data errors like this kind of leading space, will fix all those data errors. Then other than customers, you have the products. So let's look at the products table. See, product table has product name, product ID, and category. Now, if you look at the product table for parent company, it was a little different, right? Like, see here, they call product code. Here they call product underscore ID. Here is like a number, and here you can see it's alphanumeric. So these are two different companies. So they will have different names for the data columns, different way of representing this information. Then there is division and category. So you don't have division, but you have category. And then this one has a variant, but this one doesn't. So you can see that this kind of data differences occur most of the time when you are working on industrial data engineering project, and your job as a data engineer is to work through these differences and create a streamlined pipeline. Also, this is order table, right? Order ID, order placement date, and so on. And then what is left? So you have then gross price table as well. Check video description for the resources link, and you will be able to download all this data. Now you already see there are data issues, there are negative values unknown, and this kind of situation happens in real life. So don't worry, we will do the cleaning of this information in our silver layer. All right, so before starting the work on this project, I encourage you to look at all these data files, and in your brain, think for a while, try to understand this entire data model, try to understand how this information is laid out. A good data engineer will do this. They will spend time studying the data, and then it will help you during your actual work of building the ETL pipeline. Let's go ahead and create an account in Databricks. All you have to do is click a link down below in the video description, and you will come here. This is Databricks free edition. They have created this free edition so that learning community can benefit, and we truly appreciate that effort. Setting it up is very easy. I'm going to use my Google account. You can use your email ID as well. So click on continue with Google, and I will select my Google account, say continue. And here for personal use, get free edition, click on continue and start the puzzle. Okay, so I think this is the right answer. Hit submit. After a few seconds, my account is ready. I am in Databricks environment. My first step for this project will be to set up the catalog and schema and tables for my project. Now, what kind of catalog do we want to set? Well, for parent company, we already know that they have an established data infrastructure. So they have bronze, silver, and gold layer. But for this particular tutorial, we are not going to cover bronze and silver because we are going to mainly focus on the child company's data pipeline. Okay. So for parent, which is Atlicon, we will directly create a gold layer, and we will import the data from those CSV files into gold. See, in real life, they have this data pipeline set up already from many years. So in real life, what will happen is when you join Atlicon as a data engineer, you will go into Databricks and you will already see this pipeline. But since this is a learning project, you will not see this pipeline. You have to manually import that data. Okay. So let's create that gold layer. We will also create bronze and silver layer for our child pipeline, right? See, for child pipeline, we need to do it. So we'll do all that setup, and for that you need to go to workspace, and let's create a folder where we will store all our code. We will call it consolidated pipeline. Okay. And then you create a new notebook. Let's call it 1_setup. And here, if you want to create a catalog, you will say %SQL. This is how you run a SQL query. Create catalog if not exist. What should we call our catalog? Well, FMCG. Okay. Create catalog if not exist, FMCG. And usually the next line is use catalog FMCG. Okay, so let's run this code. And folks, if you don't know the fundamentals, you can refer to the foundation section in this 3 hour and 35 minutes video that we have on Code Basics channel. Okay, so this video contains the foundation section where we have covered all these fundamentals. I initially got the error because there was a syntax problem. I did not have as, but now we are good. Okay, so this catalog is created, and if you want to verify it, you can right click, open this catalog in new tab, And here you will see this FMCG catalog. Now let's create our schema. So we will say SQL create schema if not exist FMCG dot gold, and you will do the same thing for silver and and bronze layer 2. So let's execute this. Okay, so this worked okay. And when you refresh the icon here under FMCG, you see all 3 schemas. Now let's upload data from the parent company folder full load. Okay, so we are going to create tables using these. So for this, you can go to catalog, click on plus and say add data. You can do this via data ingestion tab as well, right? Data ingestion is the same thing. Create or modify table, and let's drag and drop dim customer. So I'm going to drag and drop, and here my catalog is FMCG, so that is perfect. My schema is default. Okay, schema should not be default, schema should be gold, because this data is directly going into gold layer. Okay, we are doing one-time import for this project. As I said, if you're working in the industry, you will already have this pipeline set up. So this is how my table looks. I will make one change. I will change customer code from integer to string. Why? Because customer code is a categorical data. Although it's a number, it's really category. It can be a string also, right? So that's why I'm converting it to a string. You keep things numbers only if you're going to do some arithmetic operation. Here we are not going to do arithmetic operation. We are not going to do something like, okay, customer code this is greater than customer code that. We are not going to do that. So this is string, everything is string. Let's create a table here. All right, so see, this table is created, and if you look at sample data, you will see all this sample data. In similar fashion, let's import products. All the columns here are string, so click on create table. Okay, I think I made a mistake. This landed into default. We want this to go to the gold table, so you can drop it. Maybe you can go to SQL editor, right? See here, SQL editor, and here in the SQL editor, just say drop table this, run it, and it should be dropped. And I will import it again, add data, create table, drag and drop products. Make sure you're selecting the gold schema, create table. Okay, you do the same thing for gross price. Okay, so let's drag and drop. Make sure you're selecting gold here, and product code is string, price INR is number, year is number. Looks good. Click plus again and go to fact orders. Now drag and drop here. Once again, gold customer code, you want to change it to string because we did it in the other table, and create table. All right, so all 4 tables are created, and you can just say select count star from, let's say I want to know how many records are there in my fact table. See, it has 93,000 records. And if you look at the CSV file, you can do some quick QC. Okay, so this looks good. We need one additional table called date table. So date is also a dimension table. And usually, if you look at the data engineering projects, many times this date table is created via scripting, because you don't need to import from CSV, etc. You can just write a Python code to create this date table. Okay, so essentially that date table will be the 4th component here. Okay, so it will be dim date table like this, and you will associate that date with this date. See here, order placement date, and then you can do this analytics using months, quarters, and so on. So as we move ahead, you will see how this thing happens. But for now, what I will do is I will go to workspace, and then in that go to consolidated pipeline, and I have a notebook ready for dim date table creation. So I'll just drag and drop. Okay. And this is something we are going to give you this code. So in the code folder, there is a setup directory. In that you have dim date table creation. Okay. So let's import that over here, dim date table. Okay. So in this code, let me explain what we are doing. So see, we have a start date and end date, and those dates are January 1st, 2024. End date is December 2025. Okay. So our data engineering project is for this time range. And then for that time range, we are using all this SQL queries and all these functions from Spark to create that data frame. Okay, so let me just create that data frame. And to explain this to you, we are using this explode function where you are giving start and end date, and you are saying interval. So this explode will take this start date and end date, and for 1 month interval, it's like Python range function. For 1 month interval, it will give you all the dates, and that will be your month start date. Okay, and that will be essentially your data frame. And in that data frame, once you have dates, you will add all these additional keys, okay, or additional columns actually. So let me just show you that so that you understand what's going on. So I executed this code. So see, you have month underscore start underscore date. Okay, so you created that date through that statement, and just from that date alone, you can get date key. So date key is take month underscore start date and format it in this format. Okay, so see, this has hyphen, this doesn't have hyphen. So this is like a primary key for that table. And then you have year. So year you can easily get from the date. Okay, so this year is this year from this date. Month is this month and convert it to a string text, January, February, etc. Then short month is Jan. Okay, and so on. Like you have quarter and so on. So you see, you have quarter, year, quarter, and so on. And once that data frame is set up, you will write it to dim underscore date table in your gold layer. This code is executed. Now I will go here, refresh, and I see this dim underscore date table. So see, it has all this awesome data, and this date table will be useful because when we build a dashboard, we want to, let's say, aggregate data based on quarter. So now we can do join using this particular date, right? Month start date will link it to the order date, and we can do all this analytics. All right, so my gold layer for my parent company is now ready. Let's summarize what we have done so far. So we have this parent company's data pipeline. So we prepared this gold layer, and gold layer had both the dim table as well as fact table, right? So we created that. As a next step, we are going to now take the data of child company from OLTP layer and put it in S3. And we don't have these mobile apps, etc. So we will use bunch of CSV files, and we will ingest those files into S3. And this S3 is really like a data lake. Okay, and it's just a object store where you have all your data, and from here we will ingest data into bronze layer. So let's do an account setup for AWS. Okay, and if you already have AWS account, you can skip this section for the AWS account setup. But if not, you can just follow next 2 minutes and set it up. Folks, we will be using AWS in the upcoming chapters. So let's first set up the account. You can Google create AWS account and click on this link. Here, click on create a free account link. If you already have an account, then you can skip this video. You can log into your account. But if you don't, then sign up for AWS, and here provide your email address. Okay, and then you can provide some AWS account name. I'm going to say Code Basics Double, whatever. Account name doesn't matter that much, but here you can provide your Gmail ID. Once you do that, it will send an email to your email ID to verify. So I have done the verification, and now I can provide my password. So just provide a password and proceed further. Okay, at some point it will ask you for selecting your plan. So I'm going to say, okay, free 6-month plan. Okay, so let's select that, and you can provide all the details here. So see, in the previous screen, it asked me for my credit card. It is not going to charge. Actually, they just do this credit card verification. So you will get some free credits. Okay. So you can provide your credit card details, etc. And then it will ask you for this SMS just for another verification. So here is send a code on my phone. So I'm just confirming my identity. So it will require multiple step of verification. Okay, so now see, my AWS account is set up. At any step, if you're feeling stuck, folks, use common sense. You have to use common sense. Take help of ChatGPT. Setting up an AWS account should not be a rocket science. You should be able to figure it out, folks. Okay, so please do that. And now I can go to AWS console, where I'll be able to kind of see different offerings and different options that AWS has. As a next step, we will upload child company's data to S3. Now, if you don't know, S3 is an object store offered by AWS. So here you can type S3, click on that, and here you need to create a bucket. Bucket is like a folder in the cloud where you store your data. So create a bucket. You need to give a unique name. So I will say sports bar and then DP. Now you won't be able to create bucket with the same name because it has to be globally unique. So make sure you do hyphen and you give some string which is unique because there are so many viewers watching it. Okay. And if you give the same name as them, it's not going to work. And then just click on create bucket. So it's like on a cloud, my folder is created, which is this sports bar bucket. And here I will upload my child company's data. So child company's data is in this folder. It has two subfolders, full load and incremental load. Full load contains data from July 1st. Look at this file, July 1st all the way till November 30. An incremental load contains data from December, 1st December to 30th December. Okay. So we are going to just focus on full load for now. So it's like a batch load, and incremental updates will take care of it later. So here click on upload, then go to full load, and all these folders just drag and drop. Okay. So drag and drop here. Click on upload. It will take few seconds or minutes. And finally, my data is uploaded. Okay. You can verify it. You can go to this bucket and now you see these individual folders, see order, landing, and you see all these files. At this stage, we are done with this step. Okay. So from OLTP, data is ingested to S3. And now we can move on to the next step. We will now establish S3 connection from Databricks. Okay. So from Databricks, we will access this particular S3 bucket. For this, go to your catalog. Okay. Click on catalog, click on external data, create external connection, AWS quick start, next, and here type in the bucket name. So our bucket name is sports bar DP. So let's copy this S3 colon bucket name. I think, yeah. Click on generate new token, copy this token, click on launch in quick start, and make sure you log into your AWS account in that same browser tab. And then here, personal access token is this. Okay, so you copied that. Go ahead, and I think you can keep everything default. Create stack. Here it says create in progress. It's gonna take some time. After a few minutes of waiting, it shows create complete. At this stage, you can go here, press OK, go to external connection, go to this particular connection, see S3 sports bar, and test connection. And see here, it is able to connect with S3. You can go to browse and you will see all the data that you have in S3. See orders, landing, and all these files. Now folks, if you go here and if you delete something, it's going to delete it from S3. So this is like a direct connection. It's a connection, a direct reference to your S3 bucket. All right. So our connection part is done. Now let's move this data to bronze layer. And we have dimension and fact tables, correct? So we are just going to focus on dimension table for now. Let's go to workspace. There, we have this consolidated pipeline folder, and remember we created these two files initially. This _setup, I will call it setup catalogs. Okay, so let me rename it as setup catalogs and tables, and then let me move this code into a folder. So I will call it setup folder, and in this folder I will move these two files, right? So these two files I will move it here and create another folder called dimension data processing. Now in dimension we have customers, products, and gross price. So let's start with a notebook that says customer data processing. Okay, so one customer data processing. Here I will start by importing some essential functions, and then we need to define the bronze schema, silver schema, gold schema, all those schemas. Now I can just say, okay, bronze schema name is bronze. I can do it here, but I will use a different approach. That is what people do it in the industry. They have this schema names in a different configuration file, and you can just change that schema. Tomorrow if you change this schema to something else, you can easily change it to that configuration file, and you don't have to change this code. Now that configuration file in my case is going to be another notebook. You can do it via notebook, via another Python file, or just a simple configuration text file. There are multiple ways of doing it. I'm just showing you one way. So here I will create another notebook called utilities. Okay, so this is your utilities, and there I will simply create these three variables. So essentially you are importing these variables into that other file. Okay, and you run it. Now see, this utilities, if you look at it, let's go to that particular folder, and in the workspace I have this utilities, right? So if you say copy full path and go to your another notebook, which is this, and if you just say %run, and then in the utilities you have those three variables defined, right? So I'm going to run it, and after I run that, if I print name of those variables, it will print it. See, bronze schema, silver schema, and gold schema is something that it imported from that utilities. So this way, let's say if you want to change the schema name, etc., you just change it in the utilities file, and you don't have to make any code changes through this particular file. Let us now create something called widgets. So what this widgets will do is, let me execute it so that you can see it. You see at the top, it will put all these controls. So now you can specify your configurable catalog name, your data source name, etc. here. So we are doing customer data processing, and in our bucket, the name of the folder is customers. Tomorrow, let's say the folder name changes to something else. In that case, you can just change it directly here in this UI control. And then whatever is the value in this UI control, you can get it by calling this code. Okay, so let me just show you. So you'll say dbutils.widgets.get catalog, and it will get the value whatever is present here. So let's say if I say ABC, okay, and if I execute this, okay, let me just put it in a next cell because that's needed. See, when I do that, I will get ABC. If I say customers, and if I run it, I get customers. So whatever is the value there in the UI control, you get it. And this is a common practice where people who use Databricks, they use this widget to specify, let's say, environment. If you're running in dev, alpha, prod, then you put an environment variable here. If you're running it for different catalogs, different buckets, as you can see in this example, then they use this inbuilt dbutils functionality. Okay, so now we have our catalog name, which is FMCG, and our data source is customers. The next step is specifying the bucket. So we want to get all the files from this bucket, sports bar dp / customers, and whatever CSV file you have right here. I know there is one CSV file, but it's a usual practice to specify star.csv. So when you execute this, see the base path is sports bar DP customers CSV file. Now from this path, we will create a data frame. And the way you do that is spark.read.format. Okay. So format is CSV dot load base path. Okay. And that is your DF. And let me display your DF. And see, you got your DF, but there are problems, right? Like see, it's not taking the proper header and so on. And for that, I need to specify a bunch of options. So here I will put this code. So here, what you're saying is header, it has a header, then infer the schema, then also add 2 new columns. So these are the 2 metadata columns that we almost usually add. Okay. It's a read time step and metadata file name. So let me just run it and you will see what these 2 columns will do. So see, file name is like from which file it loaded the data. This is beneficial in terms of lineage as well as in terms of debugging. And if you are not familiar with all these concepts, once again, watch the other video that we have on our channel for Databricks Foundations. Okay. So now we have a data frame ready, which has all the raw data and 2 metadata columns. Okay. So these 2. Okay. So file size, we have read timestamp and we have file name and file size, actually 3 columns, right? So see, read timestamp, at what time this data was read. You can also print the schema and you see. So see here, customer ID is integer, by the way, because we got data from CSV and we just said infer schema. So obviously, if you ask computer to infer it, it will say integer. We will convert it to string later on because in our gold layer, remember the customer ID is string. This is looking good. Now as a next step, we will directly write it to our bronze table because bronze is your raw data. You're not doing any transformation. And the way you do it is like you'll say df.write. What is the format? We are using delta format and we are doing mode overwrite. Okay. So let's say if there is already a table, you will overwrite it because we are doing batch processing and this is dimensional data. So you don't want to do append. Whatever you have, it's the first time, let's go overwrite it. Okay, just in case if there is a table. Now this enable change data feed will turn on CDF. So if you read about CDF in Databricks, you will find the information on what it will do, right? So it will allow you to track the changes at row level. I mean, if you know the fundamentals of delta table provides you certain properties such as acid, then time travel. Okay. So if you're making any changes, it will track, okay, who changed what row, all of that. So if you want to do time travel, if you want to do some kind of audit, it will be very helpful. So let's run this code now. And this should create a table called bronze. Okay. So see here, what we are doing is save as table catalog. Catalog is FMCG .bronze.customers. Okay. So we should have that kind of table. So let's check it here. And if you go to FMCG bronze, see, now we have this customers table and you can see some customer data as well. So this data will be exactly same. Okay. Whatever you have in that CSV file, it will be exactly same. Now let's start working on silver processing. Okay. So silver processing. So in the silver, you will first get the bronze data in your bronze data frame. Okay. So let's say this is my bronze data frame. And in that, you are now going to do some transformation. So what is the purpose of silver? So bronze contains raw data. Silver will contain clean data. So if you have any null values, if you have any duplicates, you will remove all of that. Okay. So let's print the schema here, and the schema looks good. And now we are going to do certain transformations. So the first transformation is we will find out if there are any duplicates, if there are any duplicate customers. Okay. So see, this is my raw file. And by the way, there is not much data. In real life, you will find a lot of, like, a huge volume of data. But here I already see some problems. See, these customers don't have city. So there are some blank values. Then, leading spaces. You see spaces? That is a problem. Another problem I see is, see, HUB, H capital and H is small. So there is always a fat fingering. And there might be duplicates. So duplicates, let's see. I mean, here I'm not able to find, so I will do it programmatically. So I will say that df bronze group by customer ID, and then you count. Okay, so let me do just this so that you know this will produce a count of for each of the customer IDs, and we want to find out customer IDs which has count 2, so that those are duplicate, right? So here, see, when you say where count greater than 1, and if you run it, so these are the duplicates that you have. There is another way of doing it, by the way. You will find in Spark, PySpark, there are multiple ways of doing same thing. See, you can do it like this also. You are saying filter whenever count, this count is a column, is greater than 1. Okay, so these are the duplicate values that you have, and you want to drop them by simply calling this particular function. See, you are just saying drop duplicates customer ID. Very simple function. Okay, and we will also print count before and after that operation. And you will notice that previously there were 39. After dropping duplicates, there are 35. So 4 drop, right? See, 1, 2, 3, 4. So it will keep the first one, drop the second one. All right, so that is drop. Now we will also trim the spaces from the customer names, right? We already saw that some of the customers have these leading spaces, right? Like, see, this is the space. So you want to remove it. And the way you remove that is you will say filter customer name not equal to this. So this will only show you which customer have those leading space issue, right? I hope you're getting the point. What we are saying is when you do f.trim from customer name, if that is not equal to the actual column, which means it has this leading space, see all of these values, there is a leading space. And to remove that, you will use this trim function. So trim function is this here. This with column is a very popular function, a frequently used function in PySpark. Okay, so you will say with column customer name, and you replace that customer name with f.trim. So take the customer name column, trim the spaces, and assign it back to that customer name. And after that, when you run this code again, let me just run it for verification. You should not find anything. It should print 0. See, no rows written. So that issue is fixed. We will also see if there are any issues with city names. So we'll find the distinct cities. Okay, you can just say select city.distinct, and it will show you all the distinct cities in your data frame. And we are again finding issues. See, Bangalore versus Bangalore. This city used to be called Bangalore. Now it is called Bangalore. Then there are, fat fingering. See, typos. Like, see, Hyderabad, there are 2 Ds. See, Delhi versus Delhi. You see all this issue, Bangalore, extra U. These kind of issues happen, folks. Like when I was at Bloomberg, we have worked with so many such problems while building data engineering projects. Even in Atlic, our AI and data consulting company, when we look at the real life customer data from, see, we were working with one big enterprise recently. And you would think, oh, this is such a big company, they will not have this quality issue, but there are so many issues like this. So this kind of issues is common. And what we want to do here is we want to provide a correct mapping, right? We want to say, okay, Hyderabad double D is actually this. Hydra, see, there is A missing. So you are fixing, right? Like wrong name to the correct name. So once the mapping is created, you will create another list called allowed. So these are the 3 cities which are allowed. We talk to business manager and say like, okay, if you find anything other than this, it's garbage. So in this logic, we will replace. Okay, so we will first replace all these values with the new value. Then what we'll say is, if city is not one of these 3 cities, then it should be null. Okay, so see, f.call is null, then none. And if it is in, then this, otherwise it's none. So if it is in this list, then keep it, otherwise make it null. Okay, so I'm going to run this and then run again this distinct command to see the number of unique cities. See, now those issues are fixed. Okay, so cities are fixed. The next problem is that title case, right? I think, let me pull that CSV file from the screen. You notice like the C here is small case, the C here is capital case. So let's fix that problem. Okay, so we'll just say distinct show, and here see this two, you see like hub h. So to fix it, we are going to use this init cap function. So the way you write it is customer name, okay, replace customer name column with this new formula, which is if it is null, then don't do anything. But if it is not null, then you just say init cap. Init cap means the first letter is capital, remaining are all small. Okay, so after running this, I would like to run the same command, customer name. And now see, those are gone actually. So when you say distinct, you will not find these duplicates. I mean, kind of duplicates. I see nutrition and capital and small. Now those things are gone. Now, one thing you noticed is there are some records with city equal to null. I want to see it. Okay, let's see what are those records with city null. So you'll say filter city is null, then show those records. So let's run this. See, Spring Nutrition, Zenith Foods, all these customers have null cities. But I think I noticed that the same customer has other cities also. Okay, so what I will do is I will create an array and I will put all this like Spring, Zenith, Primal, Recovery Lane, and then I will find all the records which has this customer. So I will say filter, if customer is in this, then show me. I want to see all the records which has any of these 4 customers. So see here. Now see, we have 3 cities, Bangalore, Hyderabad, New Delhi. So just look at these first 3 records. If it is Bangalore and Hyderabad, this has to be New Delhi, right? So if it is Hyderabad and New Delhi, this has to be Bangalore. And then you will find this kind of case also where there are only 2 records. So you don't know if this one is Hyderabad or New Delhi. So you go, you talk to your business manager, your business user, and they will provide some clarification. They will say, okay, this 403 customer, 403, which has null, is actually New Delhi. So this kind of fix, they will help you to fix this data. And then you will create a data frame out of this customer ID and city. Okay, so all we are doing is creating data frame out of this, and we are displaying this data frame. And then we will use this data frame to actually fix our issue later on. Okay, so we got this data frame. It's a pretty straightforward code. And then you will perform join. So you will say silver.join with this other one using customer ID, right? Left join. And then for city, replace null with the fixed city. So this will replace that null city. Okay, this will give you the null record. Basically, coalesce function will give you the null record. And then eventually, see, when you join, it will also create a fixed city column. So you want to drop that as well. So let's do this. And then I want to display this df silver. And here you will notice, right? 789403. So 789 and 403 now has New Delhi. See? So all those issues are gone. You don't see a city now with null. See, our data frame is getting better and better at each stage. And I will run the same command, right? Like the same code that we ran before, like this particular code, I have copy pasted and I will run it again. And see, all those cities are fixed. See, this is fixed. All these are now fixed. And the last thing you want to do is you have customer ID column as integer. Now, if you remember, in our gold layer for parent, customer ID, when we imported initially, remember it was a string. So I want to convert the customer ID to string so that, see, now customer ID is a string. It's a categorical variable, right? We discussed it before, why we are doing it. All right. Now, I want to do one last thing, which is, see, in our table, we have customer ID, customer name, and all these columns. But if you look at our gold table, right? So let me just show you gold table. In gold, where is my gold? Dim customer is here. Sample data. My column names are different. See here, my customer ID is customer underscore ID, and here is customer underscore code. Then my customer name is in customer column. Here it is customer name. Then I have these 3 extra column, market, platform, channel, which I don't have it here. So I need to create those columns. And also one more thing I want to do is, see, if you look at this data, it has customer and directly country, but this has city. So how do you differentiate, right? Like, so let's say if this child data goes into this table and you want to know whether, let's say Janet Food is from Hyderabad or Janet Food is from Bangalore, how do you know? So don't you think it will be better if for customer name, for this child table, we have customer name hyphen city. So that way it's Zenith Food Bangalore, Zenith Food Hyderabad. Just imagine, just visualize that in this table, you have customer column. In this column, you have Zenith Food Bangalore, Zenith Food Delhi. That way you know exactly like which Zenith Food you're talking about, okay? Because we don't have a separate city column in this particular table. So we will do all of this. In customer name, we will put customer name and city. That is one change. Second change is we will introduce 3 new columns, market, platform, channel. And these are hard coded actually. So sports bar, we know that it is from market India. Platform, we will set it as sports bar, and channel will be acquisition. Okay. We discussed these values with business and they're okay. So we'll say, okay, market is India, platform, sports bar, static values for all the records. And here you are saying that create a new column called customer. See, this is called customer, which is nothing but a concatenation of customer name and city. And if it is, see what this will do is if it is null, it will say unknown. Okay. So let's run this code, execute it. Now see, first of all, you got market, platform, channel. So that is incompatible with this. You have customer code. So it is customer ID here. Maybe in the next step, we'll change it from customer ID to customer code. And we have this customer column, right? So this customer column will merge to this column. And here, see, you have like city and all that, okay? Now, let's write this to a silver table. So we'll write it to silver table, silver schema, data source, okay? So let's write it. And once it is returned, you can just quickly verify by going here, hit refresh, go to silver. See, I see customers now. And there you see customer name, customer ID, etc. Right? All these 3 columns. Now for gold layer, what you need to do is very simple. See, you need these 3 columns. From silver, you pick these 3 columns. Then you pick customer column. Okay, what other columns do you need? And you need customer ID, which should be renamed to customer code. Okay, so let's do that in the gold layer. So here I'm going to say gold processing, control enter, and you're creating a data frame out of your silver table initially, and then you will pick only these columns. You will drop all other columns, right? We don't need file size. We don't need all of these columns. We need only these columns. Okay. So control enter, and then you can display it, but I know I have tested it. It works okay. And you can write it to gold layer. So here you are writing to gold schema. Okay. And the table we are calling it, see, we can't call dim underscore customers because the dim underscore customers is your parent company, right? Atlicon's table. So SB underscore means sports bar. Okay. So now when you refresh, you see SB underscore dim. So this dim customers is Atlicon gold data. This one is a gold data of sports bar. See, customer ID, customer name, city, and so on. Okay, so we got all the data in the gold layer of our sports bar customer. But when we merge, actually, see, so what we did here, let me summarize. In the gold layer of our sports bar, we kept the columns, right? Customer ID, customer name, customer. Our goal columns are little different. But when we merge, so now some of these columns, for example, market platform channel and customer will not have city and customer name because those columns are not there in the gold layer of parent data. And customer ID, we will rename to customer code. Okay, so let's do that merging part. So the last one is the merging part, and merging part is this. So you have a delta table. So this is your parent company's gold customer table, and child customers is nothing but customer ID you rename to customer code. And then the remaining columns are same. Okay, so control enter. And then you will do upsert operation. The reason you do that is, let me show you the code first. So here, what we are saying is, my source is my child. My target is my parent table. And condition is customer code. So if customer code matches in that parent, then update. But if it doesn't match, then insert. So this is called upsert operation. Up means update, sert means insert. If the customer code is same in a target table, then update. But if you don't find customer code in the target table, then insert. Okay. So we have covered these fundamentals in that other foundation video, the previous video which we had on our channel. So there we discussed this in detail. But I hope this is not that difficult. Now let me go to dim customers and sample data and see. You can say that show me all records. This is like that AI Genie feature, okay, AI feature where you just say run query and it will show you all the records. So now you see all the latest records are in gold. Remember, in gold schema, dim underscore customer table is your consolidated table. It contains everything. So now it contains data from sports bar as well as it contains data. See, this is the data from the parent company, the previous data that we have. All right, so we are done with processing of our customers table. All right, that has been quite a lot of work, and you must be realizing that as a data engineer, you have to do all this hard work to perform data transformations, data cleaning, building this data pipeline, and so on, so that eventually AI engineers and data analysts can benefit. When you are building a good data infrastructure in your company, it will produce high quality data that the other teams can use. It is like you're working in a pizza store, okay? And chefs are the people who prepare the pizza. So chefs here are AI engineers or data analysts. But they can't make a pizza if you don't provide high quality ingredients. So as a data engineer, your job is to provide high quality ingredients, the vegetables, cheese, dough, etc. Clean them, okay, and get them into a stage so that the chef, which is AI engineer or data analyst, can use it for their recipe. And that is the reason data engineers get paid very high, because they bring a lot of value to any data organization. With that, now we are going to move to products table. Now, to save some time for this tutorial video, what I'm going to do is I'm going to copy the notebooks that I have created for products dimension and the gross price dimension. Okay, you will find this code down from the video description. There should be a resource file which will give you the code. So you just take this code, drag and drop here, and let me see if this is the right directory. Yes. So you should go to consolidated pipeline dimension data processing and drag and drop these two files, and then click on products data processing. Here some of the initial code is exactly same as dim customers. You are importing some function, right? This function is very important, folks. PySpark SQL functions as F. This is extremely important. You will use it a lot throughout your PySpark coding. And percentage run is used to run a notebook. So utilities.ipynb is a notebook which has these three variables: bronze schema, silver schema, gold schema. See, we have not defined these variables anywhere, right? But since these variables are present in that file, you are able to import it. You can also create a .py file, let's say utilities.py, and have those three variables here. Then you can say here from utilities, from utilities import bronze schema. You can do it that way also. Okay, there are multiple ways of doing it. I'm just running the now notebook directly. Okay, next step is creating those widgets. Remember, we created these widgets in customers dimension processing as well. This is so that, let's say if you have dev, alpha, etc., different environments, and if your catalogs differ, let's say this is dev and dev, prod, alpha, then you can just change it here. You don't have to, mess with your code, because when you change the code, errors happen. If you're a software engineer, if you're done coding, you will understand. That's why, to keep our code safe, we use this kind of configuration, this kind of widgets. Okay, and then make sure here you are specifying your bucket. My bucket is DP, your bucket name will be different. So remember that, and execute this. So here I'm specifying the path of products. Okay, so if you look at that, in the S3 bucket, you have sports bar DP, products, and product.csv. So see, so that's what you have here. Sports bar DP, products, and product.csv. Now the next step will be to create a bronze table using this CSV file. And how do you do it? Well, it's pretty straightforward. You just say spark.read.format and specify the path. What is base path? Well, you see here, very clear. You are going to S3 through the connection that you have established, reading CSV files into this data frame, and also creating these additional metadata columns. The first one is read timestamp. So when you read the file from S3, whatever is the time, you will put it in a column. Then whatever is the file name, right? Product.csv. What is the file size? You will put all of that at a row level. So there is a lineage, there is audit tracking, and so on. So let's run this code. And once this is run, we will print the schema. So the schema is straightforward. See, everything is string here. Okay, and you can display your data frame here. All right, so that's my data frame. And then you write this data to your bronze layer. See, this is your bronze schema. So fmcg.bronze.products, it will write it in a delta format, and delta format gives you time travel, acid compliance, and so on. Let's make sure we have that table. So you go to catalog, FMCG, bronze. See, you see the product tables here. Now, this product table has a different schema and different way of presenting information compared to our gold table. So this is child company's data, right? Let me open the table which is a parent company's data, which is in a gold schema. Okay, so this is our eventual table where we want to merge our data. And you will notice differences. See, the first difference is this one has product and variant in the product name column. See, sports bar, energy bar is one product, but a variant, it can be 60 gram, 40 gram, etc. So we need to split this column and create two columns, product and variant, because that's why we have it in our parent company, right? See, product, this, and variant, 26 LB, 30 LB. I hope you can see it. So we'll split that. That is one change. Second change is here we have category column, or you look at any column, it is capital case, which means first letter of every word is capital. See, finger tab, F and T is capital. Whereas here it is all small case. So maybe we'll convert this column to capital case. Then you also see some invalid values. See here, when you talk to a business manager of sports bar, they said that valid product ID in sports bar company will have all numeric columns, but that is not the case here. In the future, you might get some invalid product IDs. So we need to do something with this invalid record. And then one more thing I noticed is the spelling of protein is wrong. See, protein. It should be PROTEIN. It is TIEN. It's a common, fat fingering. And you have same problem here also. So we'll fix all of those. Okay, so let's go to our code now, and we will do all this cleaning in silver layer. So first we need to load the data. So we are loading the data in silver layer now. So this DF bronze is a data frame, right? Which is read from the bronze schema. And first we will drop duplicate. So if you look at the records here, for child company, these two are duplicates. See, 25891101, 25891101, and the description Choco first 60 gram, Choco first 60 gram, 40 gram, 40 gram. These two are duplicates. So let's drop those duplicates first. So here I will do Control Enter. And you can see there were 20 rows and 18 because 2 duplicates were dropped. And the way this drop duplicate function works is, for product ID, it will find duplicates and it will keep the first record and drop the remaining. Okay, very straightforward. Then this is the title case fix. So energy bar, you want to convert to energy bars. So you will first find all the distinct values, and you found that everything is small case. So now you use this function called initCap, which is something we used in a customer transformation too. Here, this syntax, folks, this is a very common syntax you have to remember. So whenever you have Spark data frame, okay, and when you do with column, here you specify the column on which you want to operate. Let's say I want to do some transformation on this column. So you'll just say category. And then the second parameter here will be the transformation that you want to apply. So on category column, I want to apply a bunch of transformation. And then you save that back to a new data frame like this. I mean, you assign it to the same variable. So that's a common method of doing PySpark transformation. So here the transformation we are doing is f.call. By the way, this f is this. I hope you remember, right? This f. So you are saying f dot, okay, let me just go here. Oh, not here actually. Okay. So where were we? Yes. So you'll say f dot call. If category is null, then don't do anything. If it's null, no need to change it. But if it is not null, then initCap. So this function initCap will make it initCap. First letter capital, remaining small. Okay. So Control Enter. And as you can see, first is capital now. So that issue is fixed. Wonderful. All right, folks, we are doing good so far. Let's move on to the next transformation. And by the way, sometimes you might have a question like, how do I know how many transformation I need to apply? Because here, see, for products, we have 20 records. It's easy to eyeball and kind of find out the errors. Well, the answer is you will not get it right in a first shot. You will build a pipeline, apply some transformation. Data analyst will eventually build a dashboard on gold layer, and they will spot some errors. They will come to you. Then you will fix it in transformation layer. Then you deploy again. Then again, they spot error, you fix it. So it's an iterative process. The second way of doing it is to use some common techniques. So we use common techniques, right? Like duplicates is one, finding null values is one, then talking to business and figuring out, for example, for product ID, it should be all numbers. So you talk to business manager and say, okay, can you give me all the business rules which I can use for my transformation? And they will give you, and you can just translate that into a code. Okay. So now let's fix the spelling mistake in protein. Now see, the spelling mistake is happening in both the columns, category and product. So we will fix it in both the columns. Here, the protein word is appearing as a first word. Here it is in the middle. So essentially what you will do is in both these columns, if you find the word, this protein, anywhere in the string, then replace it with protein. And if you don't know the regular expression, what you can do is you can go to YouTube. Okay. I hope you all know about YouTube. YouTube is a very famous, popular website. All right. And you just say code basics, regular expression. I have 25-minute tutorial where I have gone into details of regular expression. Once you understand regular expression, it will give you this superpower as a programmer. And then you can use tools like Claude. Claude is the best AI model for coding. Now you can say that in PySpark, give me code to fix or let's say replace protein with protein. The word can be anywhere in the string, and we need to do case insensitive match using regex. See, it's a skill. What exactly you write to AI, it is also a skill. People call it prompt engineering. But once you know that skill, it will help you a lot. So see, here it says, specify your column name and just say regex replace. Regex replace means do the regular expression match and replace it with this. So this is the regular expression it is giving. And question mark I means case insensitive. Okay. So I is case insensitive, which means it will match protein, any variant, capital and small case, and then it will replace it. So here we are going to use the same code. See, same regular expression for both the columns, product name and category. And let's hit Control Enter. And when you execute this, you will notice that now protein, the error is fixed. Okay. The other problem we had was in our parent table, we had division column, but in child, we don't have division. So you went to your business manager and like, hey buddy, how do I place my division? So he will be like, okay, he or she will be like, okay, category X means this division A, category Y means this division B. They will give you a mapping. So I took that mapping with me and I wrote this code. So energy bar means nutrition bar. Granola and cereal means breakfast foods. Okay, so that's your division. So when you say df silver with column division, it will create a new column called division using this expression. Okay, and if nothing matches, then it will be other. Then you also split the variant. Okay, so variant is this. So let's talk to Claude again and just say that how do I extract product variant from this, right? The variant here is the weight, 60 gram, and it will give you the regular expression for that too. Now see, it can give you anything here. You can say that the variant is any string enclosed in the brackets after the product name. So you can refine your logic. Okay, don't just blindly copy paste the code. You want to capture anything. So see, anything is this. This is one way of doing it. Okay, and the other way of doing it is this one. And if you want to understand it, you can give it. But basically, I'll explain you. So see, this bracket is a special character in regular expression. So if your bracket in the string that you want to capture, you have to use this character. Slash bracket means it is going to capture that bracket. Okay, slash bracket. And then this will say dot means any character. Star means it can be visible any number of time. Okay, let me do one thing. Let me give this to can you explain this regex, and let's see. So see, slash this will match the opening bracket. Then this dot matches any character. Star means 0 or more, and question mark is non-greedy. That's an advanced concept, we don't need to go over it, but essentially this will match that 60 gram. And if you want to verify, see, you can go to regex101.com. I love this website. You type your regular expression here and the string that you want to test. So anything that you want to test, right? So here, see, drink, when you say 52.4 ml, you write anything, and in the group 1, see, it is capturing that 53.4 ml, 60 gram, it is capturing. So whatever that green patch is the information you extracted, whatever is the blue patch is what matched with it. Okay, so that's, again, it comes under regular expression fundamentals, which I have already taught in this particular video. All right, so now, so this will extract that 60 gram, whatever. And folks, for the product code, what I'm thinking is this. See, this product code here contains invalid value. Tomorrow, when we do incremental processing, you might get another invalid value. So I'm not going to rely on this product ID. What I will do is I will create a new product ID from this string. So from this string, somehow I will use hashing function, some kind of SHA, and create a new product ID, which we can use as a surrogate key. Okay. So that's what we will do in this via this code. So here I am taking a product name and I am using this SHA function. So SHA function will create unique, like a long unique identifier. And for each string, it will be different. For this, it will be different. This, it will be different. So it will create a unique number. Let me run it so that you know. And then we will also clean up. So see this, our business manager is telling that product ID should be all numbers. So if it is XYZ, it's not a valid number. Then we ask our business manager, what should we do? They're like, replace it with 9999. So that's what we are doing here. So if the string is like this, so this will capture numeric. So if you have all the numbers, then you keep as it is. Otherwise, you put 999. So what it will do is, it will keep all the other numbers same, but here is gonna put 9999. Okay. So that is this code, and you will rename product name to product. So let's run this code right here. And below this, I'm going to display this so that we can understand what has happened so far. Now see here that product number has become 9999. Okay. Also, we got this variant, see 60 gram, 40 gram. From here we extracted. Then this product underscore name, we changed it to product. We also got this product code. See, it's a long string. I hope you know the fundamentals of SHA. So it's a hashing function, takes the string as an input and gives this unique identifier. So that's the identifier we generated because we don't want to rely on this product ID column. Since there was an error, see tomorrow some other invalid identifier comes. And if we replace it with 9999, and if we are having product ID as a primary key, then two products will have the same 999 key. It's not good. That's why we want to create this code, which will be unique for all the products. Okay. And then in the silver layer, you want to select all these columns. Okay. So these are the columns that you want to have. Display silver. And this is just to reorder the columns. See, the column product ID is at the last. So when you say select this, see now it came as a first column. Okay. It's just a reordering thing. And then you write it to silver table. So control enter. Okay. So it's returned to a silver table. We can go here, maybe in the catalog, and go to silver. See in products, I see my silver table now. Okay. While it is loading, let's move on. In gold, what we are going to do is, we will select only few columns. See, we are not going to have all the columns. Okay. We are not going to have this metadata and all those columns. In the gold layer, we want to have product code, ID, division, category, product, and variant. And this is the gold layer for child data. We have still not merged into the parent. Okay. So this is the gold layer for child. Let's write it and see how do you differentiate this. SB underscore dim means it's a sports bar. It's a child data. Okay, so let's execute this. Okay, and so this is the silver layer which is loaded, and you can just quickly verify it. You can also look at the gold. See, gold, you have SB dim products, and go to sample data. So the difference between the silver and gold is that in a gold, you don't see certain columns. See, usually in gold, you will generate new columns too. BI ready columns, you will do aggregation. But here we did some transformation in silver and we don't have any new columns. Let's say you had columns like revenue and expense, and you want to generate profit. So that profit column you will generate in a gold layer. Okay. Right now we don't have any such need. So our gold layer is pretty simple. And then what you will do is you will merge this child gold table into parent. Remember our architecture diagram? We are going to merge child data from child gold layer into parent gold layer. Okay. So this is parent gold layer, dim underscore product, and SB underscore dim products is a child. Okay. So this delta table is parent. Maybe I should have named it parent table. But remember, delta table is a parent table. And this is a child. And to merge it, you will use this upsert. So when match update, when not match insert. So what this will do is it will match things based on product code. So we are not using product ID because it's not reliable. This product ID we are not using. We are using product code, which is an additional column that we have generated, right? This product code for our upsert operation. An upsert operation is if you have a record with same product code in this particular table, then update, otherwise insert. Okay. And for setting, see, we are using this. Division is source, division, category, and values. We are using this. Okay. So that's it. We are now done with the processing of products, and we can verify the dim products. Okay. You can just say select all records. And this is the consolidated table, folks. So now this should have data for both child as well as parent. So see product code, okay. And if you scroll down, so this is of course Atlicon's data, which is parent company. And if you scroll down, see, this is now child's data. So you got this energy drink products, and previously you had all the sports product. All right. We are now done with the products dimension table. Let's now process the pricing data, which is our gross price table. The first portion is same as the other code, right? You're importing bunch of functions. You are importing those variables. Then you are creating these widgets, okay? And then from sports bar dp gross price star.csv, which is this one. See, let's look at this. Gross price has this gross price CSV file. Okay. So you are creating a bronze table from that along with the metadata columns. Okay. So let's view that particular table, and the table looks something like this. You notice some obvious issues like gross price is negative. We'll convert it to positive. There is unknown price. We'll maybe convert it to 0 or something. There is this date column, which has all this non-uniformity. So we'll bring it in a uniform format. Also for product table, we got rid of product ID column. We had this product code column that we created. So we need to put that here as well. And then we'll do a bunch of other transformation. But first, since bronze is a raw data, let's write it to a bronze layer. So this catalog, okay, so if you print this thing here, this will be FMCG bronze gross price table. Okay, so that table should be visible here. Let's see. If you go to bronze, this gross price table has come up. Okay, so that bronze part is done. Now let's do silver processing. So first, from that bronze table that we just created, we are creating df bronze data frame. And then we will normalize the month fill, because month fill has so much, different formats. And the way we do it is by using this try to date function. So let me explain this step by step. See, when you have this coalesce, right? So the way coalesce function works is, so coalesce will take bunch of values. Okay. So it will take bunch of values. Let's say the values are null, 5, -4, null. What it will do is it will return the first non-null value. So the return value, okay, so if you have val here, the val will now contain what? 5. If you have this as also null, then it will contain -4. So it will return the first non-null value from the list that you're passing. Okay, so that part is clear. Now this try to date, what it will do? So it will take the month column. Okay, we have month column, right? Which is this month column. And it will use this format to convert this string. The data type of this column is string. So it will try to convert the string using this format to date, So there is another function, by the way, f2date also. This function, try to date, is better compared to to_date in a way that if it cannot find this format, it will return null. So let's say this thing is returning null. Okay, let's say this thing returns null here. Okay, In that case, it will try this another format. So it will try all this for format. Okay. And let's say you think about this first date, right? Which is year/month/date. So in that case, like for the first guy here, it will convert it to the standard date format. Okay. Standard date format. It will convert it to a date object actually. And the function will return. But let's say if it is in this format, right? Let's say if the date is in this format, let's say the date is in which format? This format. So in that case, this will return null. Because see, the format here is slash, here it's this. The second one, tell me what it will do. That will also return null because you don't have slash here, right? The actual format you have is this one, third one. So here it will return a valid date. And the fourth one, it will return null. Now the way coalesce function works is it will return the first non-null value. So it will return this valid date. Okay. So that's what it is. So let's execute this code. And then if you look at month, see they are now in a uniform format. Previously there was all kind of format. Now it's in a uniform format. Then you will handle the gross price. So gross price has three issues. It has negative values. It has unknowns. Okay, so these are the two unknown issues. That is, I think, okay, so in the comment I have written. So what this function is doing is, see, when you say f.when, this is the condition. So this condition is checking if it's a valid value. If it is negative, positive, it should be a valid value. If it is not a valid value, like if it is blank or unknown, like this unknown, then it will go to otherwise and it will put it 0. We discussed with business manager is fine. Okay, let's make it 0. But if it is valid value, which is negative or positive, then you further detect if it is less than 0. If it is less than 0, then multiply with -1. So minus 84 is less than 0. If you multiply -84 with -1, what do you get? 84. Essentially, you are converting it to a positive value. And if the value is already positive, otherwise, then just use that, cast it to double. Okay. So let's execute this. And now when you see the code, see, you notice this was negative. First value was negative. Second one was unknown. So first value negative got converted to 84. Unknown got converted to 0. Unknown got converted to 0 using this condition otherwise. And negative got converted to positive using this condition. See, all right. Next one is we will enrich this by pulling that long product ID code that we generated, right? So we are doing a join with products table using product ID. See, on product ID, and then we are getting this product code. So now if you look at the join table, it has product ID as well as product code. Remember that we use SHA and we created that long code. So we are pulling that into gross price table because eventually product code is going to be our main key. Okay. And now let's write that to a silver table. Once it is written, it's a good idea to do some sanity checking. So let's go to silver. See, we have gross price. You go to sample data and see, we see product ID, product code, month is looking uniform, gross price is good. See, no negative value, no unknown, and other things are the metadata columns. Now let's look at the gold. Okay, so in the gold table here, we have product code, month, and gross price, correct? But if you look at the gold table of our parent, let's look at the gold table of parent. It is this. Go to sample data. Here you have product code. Okay, so here you have product code. Okay, so this is parent, this is child. So parent, you have product code, and child. Okay, so this is, let me see. So this is gold, and you're looking at the silver, right? So let's go to silver sample data. So here you have this product code, you have product ID as well. Then you have month, okay, and you have gross price. So now in month, this is date, okay, month date. So this is silver, But see okay, I think these are looking good. All right, so these are looking good. So now, I think, did we run silver? Yeah, silver we ran, and now we are creating gold. Okay, so we will write it to gold table for child. Okay, child gold table. I should be looking into the child table of gold. So SB gross price, this is the table. This is child gold table. Okay, that's what it is. And this is parent gold table. Now see, the parent table has pricing per year, whereas this has pricing per month. See, you want to know for a given product, like, see, this is the same product, right? If you see, this is the same product. For this product, what is my price? I think this is the same product, right? Is it 83 or 84? Because in a parent table, for a given product for a year, there is just one price. So now we need to do something. So maybe we can use a window function. So this is a gold table, but when you merge this child gold table to parent, we can use window function and we can group things based on product code and a year. So from this month column, we need to extract year, and then we use window function. I hope you know about SQL window function. If you don't, we have a SQL course, we have SQL videos, you can watch it. And then we will use rank. So when you use window function and you rank this, okay, you will rank it based on the latest month. So whatever is the latest month price, that we will put it in a year. And we discussed this with business. I know there is not a clear logic, clear decision here. So you discuss with business, and business is saying that whatever is the price in the latest month, use that as a yearly price. See, yearly price for a product is this. So for child, use that logic. So let's do that. So just to revise, we will extract year from this month column. Then we will use window function based on product code and year, and we will rank all these 5 rows. And we want to pick up the latest, right? Whatever is the latest month. Latest month is what? Latest month is this 11. So we'll pick 83. Okay. So let's do that. So you are loading the gold price data for child. Then you have to handle 0 prices in a special way. So you are creating this new column called is 0. So if the gross price is 0, the flag is 1, otherwise 0. Okay. Is 0 is folks, it's a common flag. It's a very common sense flag. Okay. So if you have price as, let's say, this, then this is 0 will be what? Is 0 will be 0, right? Because this is not, it's because it is not 0. And if the price is 0, is 0 is 1. See, even AI is noticing that. You should be able to figure it out. So that is what we are doing in this line. Then the second line, we are using window function by product code and year. Okay. And then we will rank it, and whatever has rank 1, we will take it as a latest price. Okay. So that's what we are doing in this code. And if you look at this, see what we did is we extracted year. See, we extracted, when you do this, we have a month column. First of all, we have month column, and on this month column, see, this is the month column. When you say f.year, it will extract this, just the year part, and that you put it in a year column, right? So see, you see this year column. So from month, you extracted year column. Second is 0. So is 0 is the column that you created here. Okay. If the gross price is 0, it will be 0. Otherwise, it will be 1, otherwise it is 0. So you understood this too, right? Year and 0. See, these 3 columns were there. We created year and 0. We also created rank. Okay. So for rank, let's look at this product. Okay. I want to see how this product looks. So this product, filter maybe. Product code is product code is equal to this. I think it already filtered it by 1, so you are getting 83 price, right? We discussed the logic that it will see, this looks like a window. This blue rectangle looks like a window. So it performed that window function and it took the latest price, which is 83. So that's what you see here. All right, folks, again, if you're having issues understanding this code, take a help of Claude. and try to understand it. Okay, this is not a SQL tutorial. If I start explaining window function and all the SQL fundamentals, this tutorial will become like 10 hours long. Okay, I don't want to do that. Okay, so now you are taking the required columns, whatever you need, and then you will merge it to your gold parent table using upsert operation. Okay, so this is common. You are using product code as a matching key. If the product code already exists, then update, otherwise insert. Okay, so that's what it is doing. We are done. And now when you go to the gold for dim gross price, now dim gross price contains data for both parent and child company. Okay, so if you say all records, and if you run, you will see these are parent company product codes, but you also got child company, see, and you got it by year. So for that year, whatever was the latest price, we took it. All right, we are done with now this dimension table. We are done processing our dimension data, and we will now process our facts table. So let's go to workspace here. So here I'm going to click on workspace, and I will create a new folder called fact data processing, and then create a new notebook called one_full load. So there is incremental update, and then there is a full load. So we are creating the file for the full load, and the initial portion is all same. Okay, so we'll import the required libraries, which is something we have done 10,000 times. And let me just go to that file and copy some of this code. So I will go to the dimension data processing and copy some of the code, which is okay, running this. And then you want to print, right? I hope I don't need to explain this. We have done it enough number of times so far. And also we will make sure here you are specifying your bucket. Okay, so there are widgets, there is a base path, landing path. Now see, in our AWS we have landing folder. So see, for dimension etc is simple, right? You have a folder and you have CSV file. But for orders it's different. You have a landing folder. So this folder will contain all those files, daily files. And once these files are processed, what we will do is, see, once we consume the file in Databricks, we'll create another folder called processed. Okay, so let me create the folder so you understand. So this processed folder here, see, once you ingest data from here to bronze layer of Databricks, you move that file to processed. And this is a common practice that many companies use. When I was at Bloomberg, we used to do this a lot. You have your Unix machine where you are processing some data. The daily file is processed. You move it to your processed folder. Okay, so that's what I have specified here. So let me run this. All right. So see, orders landing, order processed. Okay, landing path and processed path. And then you will create the table using your landing path, right? So when you run this, it's going to take some time, because see, at this time, what you're doing is spark.read, your path is landing path. What is landing path? It is this. And if you look at that path, see, you want to take all these files, all these files, and you want to create a data frame. So this DF will contain data from all those files. And this is the beauty of Spark, that it can read all those files seamlessly. It can also infer schema. You have all these parameters and so on, right? So let me use display function here. Let me just say display df dot limit, maybe 20 rows, because show will sometimes show it in a not in a very good format. So see here, your fact table has order ID, order placement, customer ID, order quantity, and some metadata columns. Okay, So this looks good. So this is your bronze, and you will write that to your bronze table, right? This is pretty straightforward, and you will use append method. Okay, so your bronze table is essentially, this is child data. So let's go to bronze, and in bronze we had so far customer, gross price, and products. These were our dimension table. Now we just got orders table, and if you look at this sample data here, it will show, I think, let's see, yeah, this is done. Okay, we'll come back here whenever it loads. And the next thing you want to do is you want to move the files to process. See, we loaded data into bronze, right? So let me see bronze is loaded. So now these files all these files we need to move to process folder. Process folder is empty right now. Okay, so how do you do that? So first, there is this dbutils module. When you say .fs.ls landing path, it will give you all the files. See, it will give you files as a list. See, all the files. It gives you all the files as a list. And then those files, you will go through each file. And for each file, you will say dbutils.fs.move. MV is move function. Move this file to processed path, and file info.name. See, file info.name is this, correct? So this will move it. So let's run it. It's going to take some time. Now, see, it's going to S3, and it is doing the hera-fairy, the transfer of these files from landing to processed. So now when I go here into processed, I see some files. See, maybe it's not all the files. Is still landing will still have some file because it's still actively moving it. See, it's still working on it. Okay, so let it do the work. Let's now focus on our silver processing. So for silver, you will load all the records from your bronze. Okay, so that is one thing you will do. I think it will execute after this line, so we'll have to wait. And then let's think about the transformations. So for transformations, we can see some clear transformation. So this transformation is similar to what we did with the gross price. So the formats of dates are different. So you want to bring it to a uniform format. That is one change. Order quantity has null. So you want to handle that as well. Then these are the metadata columns. Okay, product ID, let's see. Customer ID is good. I mean, customer ID is invalid. See, some of the records has invalid. I'm thinking product ID might also be invalid in some of them. So we need to handle all these scenarios. Okay, so first let's handle the order ID null, right? So order quantity is null. What should we do? Well, we can just filter out the records. I mean, based on how many records are there, you can filter out. You talk to a business, your business, and business said, okay, it's okay to filter out those records. So you filter it out. Then for customer ID, we want to keep, we have done this before, right? We want to keep those customer ID which are numeric. Others, otherwise, you know, see this, what this regular expression will do is, if it is numeric, then you use the customer ID. Otherwise, if it is non-numeric, you use 9999. Okay, so that's what you will do as a step number 2. Third step is, let's look at this order. See, you have this Tuesday, July 1, 2025. You want to remove Tuesday. We don't care about weekday, right? We care about the date, July 1, 2025. So how do you remove it? Well, you can ask this to your friend, right? ChatGPT. If you have a regular expression, you will figure out. You want to look for the portion after first comma. So you look for comma, okay? And in that comma, everything is, you have a bunch of letters, and then you take the other portion, okay? So now I want to check the scenario where if you have July 1, 2025, then you don't want to miss it, right? So you want to exclude number, just the text. Okay, so for that we can use a regular expression which looks something like this. So here the regular expression says that, okay, this is the comma, this is the first comma, right? This is the first comma. So before this first comma, if there are any A to Z character, okay, which means this Tuesday, right, then replace that with this space. Okay, and after comma, if there are any, see, after comma, this means any white spaces. So after comma, see, you have white space. Okay, so then you're saying that replace this entire thing with space. So when you replace it, what do you get? July 1 this, right? So that's essentially the purpose. See, if you do 0 to 9, right, then that will be a problem, because if you have a string like this already as an input, it will then remove this. You don't want to remove it. You want to remove only the day name, which will not contain any numbers, right? It will be just letters. So therefore you don't have 0 to 9 here. You can understand this by Claude. Okay, we have discussed this before. If you don't understand this regular expression, go to Claude, say that, okay, explain me this, and it will be a nice teacher and it will explain you with a lot of patience. And then the next one is for order placement date, right? Here you want to make it uniform. This is something we did already in gross price. We are just doing exactly the same thing. And we want to also drop some duplicates. So the duplicates are basically, if there are two records which has exact same order ID, placement dates, customer ID, product ID, and order quantity, or 5 columns are matching in 2 records, then you keep the first one, drop the remaining. At last, you want to convert product ID to string. Okay, so this is transformation number 6, product ID. We are converting it to a string. Okay, let's execute this. And then we want to also check for what is the minimum and maximum date, right? So we have data till November 30, from July to November 30. Okay, all right. Now let's see how my df orders looks. Okay, so display df orders dot limit 20. Okay, all right, let's see. Order placement date is all uniform, looks cool. See, here it was all messed up. Where is it? Where is my order ID? Here. See, here it was like string and all different format, but here now it's uniform format. Also the order quantity is not null. See, we dropped those records, and then duplicates are dropped. Customer ID, if it was not numeric, we took care of that. Okay, so my data frame looks good. Now one thing that it doesn't have is that product code. See, it has product ID, but it doesn't have that long product code. Remember that SHA that we created? And how do you get it? Well, that product code is present in this table, correct? df products. So let me display df products limit 5. So this product code is present here. I want to get this product code into this table. So we can do join using this product ID, correct? So we have product ID as a common link, and using that we can do join. So df orders dot join df products on product ID, and then select these columns. Okay, so now when you do display df join dot limit 10, it should have that product code. Okay, so other columns are same. What you got is at last this additional column, which is your product code. Once that is done, you will write to your silver table. Okay, so you will say that if the table does not exist, then you create it, right? This is similar to all the other code we have written before. If it exists, then you want to do absurd, correct? Because see, for fact table, we are doing batch processing as well as incremental updates, daily updates. So that is the reason even when you are doing full load, I mean, ideally you would do this in your incremental update, but even in full load, just to be kind of sure, sometimes your code doesn't work, you want to rerun, there can be other reasons. So if table exists, then you want to merge it, right? So this is that absurd code. Okay, so once you are done running this, you will find a table in your silver schema. So let's go to silver, and now see, this table just appeared. Wonderful. All right, we are done with the silver schema, and now we will start processing gold. And by the way, you can always use this markdown. Okay, this is gold, and the gold table is, first you read from silver. Okay, so this is, although I'm calling it df gold, actually it is silver. Okay, because I'm preparing, I want this df gold to be the actual gold. So here we are not generating any BI ready columns, etc. So we will just write it to gold table, right? So creating new using the same absurd concept here to write that table. Okay, so it will be the same table. So here let's go to gold, and you can see that this table is, you see, SB fact orders. Okay, so that's the table. So gold table here, if you just want to verify the name, it is the SB fact order. So that's the table we wrote here. Okay, now we want to merge with a parent company. So let's write a markdown, merge with parent company. So this is just the child data. Okay, this one is only the child data. We want to merge this to parent. And when you start merging to parent, you realize one thing. See, let me open the parent table here. So parent fact order looks something like this. It has the quantity for, so okay, fact orders. It has the quantity aggregated at the month level. So this customer, this product, for January month, they ordered total 161, which means all the dates in January. Okay. Similarly, you will have February, March, and all that. So here the schema is such that although it says date, actually it's, I mean, ideally I should not have this date. It is actually January 2024. And you're just using the first date. Whereas in this table, you have daily level data. So now when we merge to parent, one challenge that we need to tackle is, in child, aggregate all the data from a same month and then upload to parent. Okay, so let's do that step by step. First step is, of course, you will load the child. So see, this is a child, right? So now you want to aggregate for a given product code and customer code. You want to take all the transactions in a month. So let's remove this date, and or let's change this date to 1. So if it is July 10, July 14, whatever, let's just change this to July 1st. So essentially we are talking about July month, not individual date. And then we do aggregation based on product code, date, product code, and customer code. Okay. So I hope you're getting the point. So first, change the date to first day of the month. Correct? So if it is 2025, let's say 07/10, you will make it. So let me do 12, right? So 12, then make it 1. Okay. Then if it is 13, then make it 1. I hope you're getting it. So this way we are aggregating things at the month level. All right. So let's see how many records the child has. So my child has 4811 records, and now I want to extract month. So by the way, to extract the month from this, you can use this function. Okay. So when you say df child with month start, right? So it will take this month start in the child. Actually, in the child, you are taking the date and creating a new column called month start, and this function will essentially give you this, right? For this date, it will give you this. So just remember that. And we are doing the nested group by operation. Once you got all these months, then you group by that month, product, and customer code. See, month start, product code, customer code, you are doing group by, and you want to aggregate all the sold quantity, right? You are just it's like you sold 10 cricket bets today on 2nd July, and on 4th July you sold 5 cricket bets, meaning same product to same customer. Then for July it will be 10 and 5, 15. So that's why you are doing sum of that. And then you will rename, see, this month start date you will rename back to date because our parent table has it as a date. Okay, so that's why we are renaming it to date. And then display df monthly dot limit 10. Let's execute this. See, by the way, you can do some QC on your own, and that's it. Okay, df monthly limit, and then df monthly count. Okay, this is the count, and the last one is, this is gold parent data, and you are merging it with same upsert logic, folks. So nothing new here. Now when you look at the parent data here, right, and if you say okay, so let's, okay, show me, I think all records are going to be too much, but I'll run it anyway. Okay, so I just ran a query with a specific product code. See, we have this product code, right? Just to make sure the data has landed into the parent goal table. And in fact, it has landed. See, so we have fact orders table in goal schema, which is the consolidated table containing both parent and child data. See, this is child data, right? These kind of long product codes are from child table. All right, folks. So that's it for the full load or the batch processing for fact table. Let us now understand how incremental load is going to work. Incremental load means you have bulk loaded your historical data, you have done your backfill, and now the system is up and running. Now every day when transactions happen, every day at night at, let's say, 9 o'clock when the business is closed, the OLTP system will drop the file for orders in S3 bucket. So let's say this is the file for 2nd December.csv. Okay, and once you get this file will be ingested in Databricks. Now in Databricks we have 3 layers, right? So we have bronze, then silver, and then gold. Okay, so let me just draw these boundaries, and it already has the historical data, right? So this bronze has historical data, so I'm going to mention it using green color. Okay, this silver also has historical data, whatever we backfilled, so that is also represented with this green color, and this gold also has the historical data. And by the way, this is all child. Okay, parent gold is different. So let's say we have the layer for parent gold, and it is this particular database which has all these records. So this is parent plus child, right? This is the main table, parent plus child, and this gold is that table which starts with SB underscore. Okay, now when this 2nd December file comes in, you want to append that data into bronze. So let's say this 2nd December.csv is this purple. it is this purple data. Now, what we are going to do is create another table called staging table. Okay, so let me do this. So let me just change this back to purple. Let's draw a staging table. So there will be a staging table here. Okay, there will be staging table here too, by the way. And let me explain what this staging table is. So staging table will contain only the 2nd December data. So only incremental data. That way, when you are doing transformation, see, in your daily update, when you're doing transformation, you don't need to touch this historical data. That is already done. So staging table will allow you to keep the new data. This is all the new data, which we have not seen so far. And you transform it and you put it in this staging layer of silver. You have to also add it to this, right? Because this silver layer should contain all the data. So you do that. Then from this staging, you add it to gold. Okay. In gold, you don't need any staging table because at that point you are done. And then from here, we do our merging with parent in our usual way. So this 2nd December data, we will put it here. Okay, so this will be our architecture. I'm going to copy the file for incremental load. So see, from here, we can just simply drag and drop. So let me go to this place, workspace, and let's go to consolidated pipeline, fact data processing, and drag and drop this incremental upload. Now transformation, etc. will be same as full upload. There will be few changes related to staging table. Okay, so here, let me copy this particular line. Okay, we have seen this enough, so I don't need to, I think, explain. This is all pretty straightforward stuff. So I'm running it. Then let's run this. And let's run this. And at this point, okay, let's just change this to DP. Okay. And we are just creating all these tables. We are just initializing variables, by the way. We are not doing anything more than that. And let me also print this 3, right? So see, bronze table, silver table, and gold table. You should not get confused, folks. These are the tables of child company. Okay, see, SB. And for silver and bronze, we anyway don't have parent data. So these are all the child companies table. Now here, we will be reading files from landing path. Okay, so landing path. So let's see, what do we have in landing? So in landing, we don't have anything because we processed all the files. In processed, we have files all the way till July, right? July to November 30. Okay. Now, assume today is 1st December, it's 9 o'clock, and we are going to now drop that data. So let me get that. So you go to incremental load orders, and this 1st December data, you're going to drag and drop. Okay, so let's click on upload, and in the upload, 1st December, let's drag and drop here. Okay, so see, orders landing, upload. All right, so my landing folder now has 1st December file. Okay, now what I will do is I will read it into data frame, right, from landing. So when I read it from landing folder, I will get only 1st December data, and you will see it in a row count, right? This row count is not going to be very big. It will be, I think, whatever 300 or 400, whatever number of records we have for that 1st December file. This one. Okay, so let's check this file. So I have opened that file here. And if you look at this file, we have total 350 records. Okay, so 350 records, and here see 350 records. So we have data for only 1st December, and this is incremental data. And we will write that to bronze in append mode. See, folks, let's be very careful and vigilant. Okay, you need to pay attention here. So I'm talking about this bronze folder, which has green, which is historical data, and this purple is 1st December. We are just inserting that. So now when you say append, see append, this is important. The data frame, whatever 350 records data frame has, it will be appended to that bronze table. And if you want to verify, you can verify it. See, you can verify it by going to catalog and click on the bronze, orders, go to sample data. You can say get me total count, and it will do this, and you run this query, and total count is 51,810. Okay, now when you upload to bronze table, okay, what is bronze table? Okay, let's verify it. Bronze table is bronze.orders, right? So here it is bronze.orders 51810. We are appending it. So 51810 plus 350 is how much? 52160. So let's go here. Total count. See 52160. And when you refresh, by the way, you have to refresh it. Sometimes it takes time. So I went to other tables and came back, and see, now you have 52160. Okay, so it inserted those 350 records, and we are also creating this staging table. See, staging table. So that's a new table that we are creating. So this is done. Let's refresh it, and here you see staging orders. Now this will have 350 records. Okay, so count. So when you say count, it will execute the query and see 350. Okay, so that staging table is this brown table, and we also inserted data into bronze. Okay, now from this staging we are going to create the silver, okay, and also the silver staging table. And by the way, before that, you need to move the file. So we are moving file from landing to processed. Okay, so landing to process. So now when you refresh, this file is gone. When you go to processed, all the way down, you will find December 1st. See? All right, that worked as expected. Now let's create a silver table. Okay, so from staging, see now from staging. So what you're doing is you're using this staging data because it's just a new data, and you will do all the transformation. Which transformation? Well, the same transformation that we did previously with the full load. Same transformations. Okay, same transformations we are doing here, and we will see that now this df order data frame contains data only for 1st December. Okay, we will join it with product for obvious reason, because we want to get the product code. That is something we always do. And then we will write to silver table. Now, okay, so we are writing to this silver table. What is that silver table? Well, that silver table is the main child silver table. So this, okay. So from here we perform transformation, and we are writing it to this particular silver table. And we have append. Okay, so append, it's gonna append because see, if table not exists, then it will do this, but table exists in our case. So it will merge, right? It will merge, it will do upsert, whatever. And let's see. Okay, so that is done. And you also write to staging table. Which staging table? Well, this brown table that you see here. We are going to write to that table, and that's it. Now from this we can write to our child sb_child goal table. So let's first get the data from staging. Not that we are just, notice staging underscore, we are getting this data frame from staging, 350 records. Okay, so count will be 350. Okay, 261 because we did transformation, we removed some duplicates, right? Here during transformation we removed duplicates, did data cleaning, and as a result, we got 261 records, which is okay. And then we are going to push that to goal table. So what is my goal table? My goal table is nothing but SB fact orders. Okay, SB fact orders is this, the child goal table. So here we will upsert. Okay, this is usual code. Now this is important. We want to merge the data with parent company. So in parent company, what happens is this. See, in this parent company, you will have the, let's say right now this is 1st December, but let's say you're processing 5 December, then you will have data from 1st to 4 December, right? And it is at monthly level. See, in child goal table, it's okay because it is at daily level. But when you go to parent, you want to aggregate it at monthly level. Okay, so let's verify that. So let's look at child. So see, SB fact orders is a child table, right? Data is at daily level. See, 19 July, 14 July, etc. But when you look at the goal of parents, which is this, the data is at monthly level. So although you have date, it's actually month. So essentially what is happening here is, let me just write it. So in this child table, you have data for, let's say, 1st December. When you process 2nd December, you will have 2nd December, 3 December. You will have separate records. But here, you have just December. Correct? So what you need to do is, you need to, from this table, see, let me just show you. Here, you are going to silver schema. And from staging silver schema, you want to get the month. So see here, what we did is we created this incremental month df, which is nothing but just a data frame with the start of the month. Okay, so you have December. This is December. Okay, and then this code is important. So here what we are doing is we are selecting some records from SB fact orders. So SB fact orders is this one. And then we are joining it with incremental months, which is this, on start of the month, right? So essentially you are getting all the records. So this 1st December, 2nd December, 3rd December, all these records will be in green, right? So let me, I think, to remove the confusion, so let me just draw it using green, because see, if you have green, that means data is that green. This data is coming from here. Okay, so that data you have 1st December, 2nd December, 3rd December, and so on. And let's say this file that you're seeing, let's say this file is, let's say 4 December.csv. Okay, so 4 December. So now you want to get all the quantities from here. Let's say there is 10, there is 5, and there is 2, and this one has 7. So you want to get all this historical record first, and then this record, and aggregate all the quantities. So 10, 5, 15, 17, and 24. So now when you write it here, then December will be this 24. Okay, so that's a kind of aggregation that we are doing here. So at this point, when you run this monthly table, see, monthly table, what it will contain is all the records from historical data, which is green, from December. See, all the December records it contains. Okay, so let's see what dates we have. So monthly table has a distinct date, which is this. So all the December records. Okay, and then what you do is, then you take your this one, df child, right? So you are taking df child. I think you're taking df child. No. So here you are taking monthly table. So monthly table is this, right? All your December data. And that, by the way, this new data you have already merged in this gold table, correct? So that data, that new data is already there. So you are just taking that and you are just doing grouping. So you are grouping by month, start date, product code is this, and you are doing sum of sold quantity and that, right? So when we are doing this, folks, understand that all these records are coming from gold table only. And you are doing sum, and you're doing sum of quantity, which is 24, right? So that is the sum function here. And eventually you rename your month start date. This is something we have done before. So you do this, and then when you do count, 217 records are there in total for December. Now see, right now it's 1st December, so it's just incremental file, right? But scenario I presented is this will happen when you have 2nd, 4th December. Right now it's just 1st, so it's understandable. And then you write it, you do upsert operation as usual and write it to fact order. So this is your parent table. And once this is done, you clean up your staging tables, right? Those staging tables are not needed. Now let me process the other two files. So here, okay, where is my data? So let me go to orders and see here, orders, landing. In landing, let me draw like 2nd and 3rd. Now let's see what happens. That will be interesting because you already have now 217 records, and from, I'll just say run all. Okay, let's see. Okay, I forgot to upload. So okay, upload succeeded. So upload succeeded. And now I was getting some error, by the way. Okay, now I'll say run all. So let's see, it is running. And I don't think I need this. Okay, whatever. Let's keep it as it is. And here, see 2nd and 3rd December, right? We process that. And number of records it should print somewhere. See, the two dates combined had this 528 records. Okay. And then when you merge with the parent company, see, here you get the records from 1st, 2nd, and 3rd. I hope you're getting the point, right? So the 1st is historical, and 2nd and 3rd is this incremental. So that combined is 789. Okay, folks, see, I will encourage you to debug it. Just stay calm. I know this can get confusing. Pause the video, take a break, okay, take a sip of water, go for a walk, and try to consume, try to digest this information. This is not that hard. It's just that you have to have the patience. See, you get rewards in life by doing the deep work. Just by scrolling on Instagram and getting instant dopamine, you're not going to get much help. The real reward comes after grunt work, after doing a lot of hard work and without losing patience. Okay, so I hope you complete this project, folks. Promise me, you have to finish this project. I know it might be a little difficult, but finish it. You will separate yourself from the rest of the crowd and you will build some amazing skills. All right, so that's it. And if I refresh now, see that file is gone, and you can check in process, you will find it. Okay, let's drag and drop all other files, right? So from 4 till 30, I am going to upload. So here in the upload, 4 till 30. See, did it upload? Yeah, 4 till. So started with, okay, this 28, whatever. See, 29, 30, I think it's not in order. I was just confused, like what's going on. Okay, so here go to landing, and in the landing you will see 4 all the way till 30. And I go to this code, click on run all button. See, it will take time because there is some data that it has to process. So it's going to take time. Okay, that's it. It is done. I can check my order table. Here you can say that order by date descending. Okay, so let's run this and see, you are seeing all December data. You don't see individual dates because remember we normalize data to month level, so it will be always 12/1. But if you go run the same query in SB fact orders, you will find it. So let me just run it. So order by date descending, and then let's run it. In child table we have day level granularity. See, 12/30, 12/30, 12/29, and so on. All right, wonderful. Our incremental load, incremental daily processing code is complete. Just to summarize, in the incremental load Jupyter notebook, we use this architecture essentially. So we just created this staging table. When we perform the full load, we didn't have a need of doing this staging table, right? It was just straightforward. But in incremental load, we created a staging table and we completed it. All the code is available here, and folks, I hope you are practicing along with me. Let's set up the orchestration now so that this pipeline can run automatically daily, okay? And the way we are going to do it is we will go to jobs and pipelines and we will create a new job, okay? And here run a notebook. So what is the notebook? So let's specify the path here. So the path is going to be let's see, consolidated pipeline, dimension data processing, customer data processing. Okay, so first you would like to do dim processing customers. Okay, so you are processing the customers in the first go. Okay, and the parameters. Okay, so what are the parameters? I think we had catalog, which was FMCG, and we had data source, which was customers. Okay, if you don't know what I'm talking about, then let me just show you. So here let's say if you go to workspace and consolidated pipeline, customer data processing, here see, catalog is FMCG, data underscore source is customers. So those are the parameters we are specifying here. Okay, remaining things look good. So just say create task, and then you can clone this task. So now let me just reduce this, and you click here, clone the task, do the same thing for products, right? So products, clone, and see here you see the products, right? So this products has a dependency on the customers, right? So when you do that, you will see this kind of arrow here. You of course need to change the path here. So here you will say customer data processing, and then the data source will be product or products. So let's check that. Is it products or products? Okay, let's see. So here if you say products, okay, products. So products, save the task. So task is saved. Once again clone it, and dim processing prices, right? So that's the other one, and this pricing actually depends on, okay, let's set up the notebook. So this is the pricing notebook, and it depends on the products. Okay. And what is the parameter? So it will be catalog FMCG, data source is gross price. So let's copy this. Setting this thing is very straightforward, folks. I don't think there should be any confusion. And then you will have fact processing for orders. Okay, so orders, fact processing, let's clone it. And that one depends on the pricing. Okay, so we are executing things in sequence. You can also execute things in parallel based on the use case. Here it makes sense that we execute things in this particular sequence. And what is the parameter? So let's go here, consolidated pipeline, incremental load, right? So data source is orders. Okay, so you will say orders, and the notebook is going to be incremental, right? See, pipeline is for incremental load, not for full load. So this is incremental load, save task, and that's it. See, this pipeline is set up now. You can run it manually, but before running it manually, let me do this. See, we have data in our goal table till December 30th, right? December 30, actually 30. So let's say goal table. This is our final table, right? Fact orders. And you can say that, okay, it's starting. Meanwhile, what I'll do is I have created new file quickly for 31st December, and it has a couple of records. Okay, so that file I'm going to drop to my landing folder, because right now my landing, it's all processed. So let's drag and drop that file here, 12/31, right? So I'm uploading. Upload is done, and here it is still starting. And by the way, you can set up the schedule here, right? Schedule and trigger. So usually for this kind of job, we will say that this is scheduled for every day at, let's say 8 p.m. Once the business is closed, let's say every day at 11 p.m. Once the business is closed, all the transactions are done. Every day you want to run it. So when you do this, okay, so let's say 11 is 23. So at 11 p.m. every day, I want to run this. And this is, by the way, Unix cron syntax, right? If you are aware. So I will say save. And when I do it, see this will run it actually. So if I leave my computer at 11, it will automatically run. And that's how people set it up. But right now it's a learning tutorial, so I'm going to pause it. So let's just pause it. And let's go back here. And here you can say that find max date. Okay. Find max date. And the maximum date here. Actually, maximum date here will be 12/1 because this is monthly aggregated data, right? We should look into this SB fact orders and find max date. And here we should see 30 December as the max date. Now our pipeline is kind of ready. So let's run it. Okay. So by the way, you can give job parameters, what kind of compute you want to use, tags. You can edit notification, by the way. Okay, I want to get notified via email for failure, success. Oh my God, you can do so many things, right? Email, whatever. And then permissions, advanced setting. You can just explore, folks. It's all common sense. Let me run this pipeline right now. And see, this is now running. Okay, so when you click on view run, and before we run, let's just say that this is FMCG incremental update, whatever. And okay, so this is running. So let's go to runs. And in the runs, you're seeing this thing is running. So if you go here, see this thing is processing. Now the dimension table, these are like small tables, okay, and they don't change much. So we can process them daily. The thing that we need to be careful is in fact processing, make sure you are doing incremental update. You're not doing full load every day, right? Every day you are loading just that day's file. So that's why we have incremental load here. And for remaining thing, whatever dimension tables are in S3, it will just get it and overwrite it. If you look at our code, we are overwriting it. So that's how it will work. After some time, my pipeline is done and you can see all green. Just in case if you face any errors, then you can click on it and you can go to the notebook and you can debug it. If there are any errors, you will see red mark here, okay? So our pipeline worked okay. And what we are going to do now is in our SB fact orders, go to sample data and you can say select max date and you should see the 31st December because see 31st December. So it worked okay as per our expectations. One last thing I want to cover in the orchestration part is that for parent, when we started, we had data till November 30. But for parents also, as the day pass by, there will be incremental data, correct? So for parent company, there will be incremental data. And we have not covered the pipeline for parent in this project. The project was all about child company, which is sports bar data pipeline. So, but if you're working in the company, there will be another pipeline running, which will take care of incremental load for parent. So if you look at it, this is parents data for December 2025, and it is aggregated at monthly level, right? So you will see something like this. So let's ingest this data into Databricks so that when we do dashboarding, we have a complete picture. Just remember that whatever we are doing right now, that's not what will happen in the real life. In the real life, as I mentioned, there will be a separate pipeline for parent, which will run on a daily basis, or let's say aggregate, let's say at the end of the December, and it will ingest all the data. Okay, we are doing it manually because we are not going to simulate parents pipeline here, right? It's out of the scope. So here, just say add data. Okay, click on add data and upload files to volume, and you just drag and drop this incremental load of parent. Make sure you are selecting the right folder. Okay, parent company incremental load. And then for FMCG, we will say gold. Okay, in the gold, we are going to create a volume. So parent incremental update. Okay, I think this looks good. Click on create and upload. So what has happened now is if you go to catalog and go to gold, in the volumes you see now this. Now you can go to SQL editor and run this query. So we are going to provide you the query. Okay, so this query, let me just make it small, and let me hide this. So this is the query we'll be writing. So here we are saying copy into gold fact orders. Okay, file format CSV, header true, and then select from this, select date, product code, customer code, and sold quantity. We are just casting it to the appropriate data type. You just say run all, and it says that this volume does not exist because we need to copy the path of that volume. Okay, so let's go here and gold volume this, and here make sure you're copying this path. Okay, so copy path here, and okay, so that's the correct path. You ran the query, and before running the query you can verify, okay, how many records are there. See, number of inserted rows is 4485. All right, so our data is complete. We have data for parent till December, we have data for child till December, and it's in terms of our data model, right, which is bronze, silver, and gold, all the layers are complete now. One common practice in the industry is that before people build the BI dashboard, they will create one huge denormalized view or a table, which contains all the columns from fact and dimension table. So just think you're performing a big join between fact table and all your dimension table and creating one flat table, which has everything. So now when you create your BI dashboard, you don't have to look into multiple tables. You have a single table where you have all the information. Now this will of course duplicate some information, some columns, but from dashboarding perspective, it is very fast approach. So we are going to create that, and we will do it by creating a view. Okay, so we will create this big view and we are going to provide you a query so you can run it. So just think about this view in your gold layer where you have date, product code, customer code, you have all the date attributes, customer attributes, product attributes. Okay, just look at this query, how beautiful it is. Metrics, you have sold quantity into price, which is your total revenue. Okay, then you have customers, products, you have everything. Okay, let's execute this and then we'll do select star. Okay, so let's run this. Once again, it is creating a view. We are not creating a table here. Okay, just creating a view. Now see, look at this table. It has date, product code, customer code, date key, all the attributes, Jan, quarter one. Now if somebody is building BI dashboard and they want to get a revenue by quarter, they can easily get it. There is a single table which answers all your questions. See, platform, category, product, and so on. Okay, so you can see that in, so if you go to catalog and if you refresh and if you go here, see, you will see that view over here. Now you can make use of Genie to get some quick answers. So let's create Genie by using FMCG, gold, and this. So Genie is the AI assistant offered by Databricks where you can ask questions. Okay, so here you can say that, okay, explain the data set. What is the average sold quantity of products? Okay, so you can say, show me total revenues by quarter or by year. So AI will take your question, it will convert that into a SQL query, because see, if you look at this code, it has essentially ran that SQL query. So if you know SQL, you can verify that code as well. Okay, and then it plotted all this. See how beautiful is this? See, total revenue, and you also get this plot. So this is like a quarter by quarter revenue. You can also say what are the total revenues for each product category by quarter, what are the total revenues by customer for each quarter. Okay, so I will type a different query. What are the top 5 customers by, let's say, sold quantity, instead of, you can say revenue also, but I want to know which are the top 5 customers which bought the maximum amount. Say Fitness World is number 1, Fast Track Sports is, this is so cool. See, you are seeing all this. And then what are the top 5 products by revenue? Say for Apple, company like Apple, iPhone will be number 1. Then it will be iPad or Mac, you know, something like that. So here, see, my cricket bat is selling maximum because it generated this much revenue. Okay, so I encourage you to ask different kind of questions and utilize this Genie feature. So that way you are building the skill of doing data analysis in this AI driven world. All right, the last step is to build the BI dashboard. Now this is something that will be done by data analyst, but we will do it so that you understand how the work that you are doing as a data engineer is going to be used by the other team. In Databricks, we have this option dashboards, and this is something very unique about this platform, where it is called unified platform. Basically, you do your data engineering, your data analysis, AI, everything in a single platform. So let's create a dashboard here and we can call it Atlicon Sales Insights. Okay. Sales Insights or Business Insights. Okay. Atlicon BI 360. Let's call it that. And we can have a page called sales. You can have different views, sales, marketing, supply chain, and so on. And here we can connect first with data. So you can say, okay, add a data source, right? So basically you're going to gold and selecting that view. This view is the only thing that you need, okay? If you want, you can write a custom SQL query as well, okay? So warehouse is starting, it will load in a few seconds, but you can connect with direct table or view, or you can create it from a SQL. So you can write custom query, SQL query, and the output of that query will be the source for this dashboard. While this is loading, I want to show you a preview PDF file. So see here at the top, what we'll do is we'll put filters, right? Like year, quarter, etc. And then we'll have KPIs, revenue, quantity, etc. Then you have top products by revenue, revenue share by channel. You can have monthly trend chart. See, the exact dashboard depends on the business requirements, okay? You can have all customers by revenue, right? See, quantity and revenue, top variant by revenue. You can do so many things. You can have this kind of chart where scatter plot, sold quantity and price, and so on. Okay, query has succeeded. We are not able to show the results. Okay, I don't care about that. Let's start building the visual. So the first thing is I will put this particular, just the string, okay? So just the text. So we can say sales insight, okay? And this one we can make it 30 maybe, 36. It's going inside this. Okay, let's call it sales insights. And then select it and here make it 30. Okay, see, for this you can change the background, and in the background, let's say I'm gonna use this particular color. So let me switch to light mode, and that is the border color is this. Okay, and what else? Make it center line, make it bold. Okay, I think it switched back. Okay, all right, I think something is going on. All right, let me just change this back again. Okay, I don't know why it keeps on switching back, so I'm gonna stick to this. So we'll just make this text color. Okay, let's make this a black color. All right, and let's make this center line. Okay, then you will have the visual. So let's add visualization here. So this is the visualization, and we are going to have counter. So I want to know total revenue. Okay, very simple. So here the value will be total amount INR, and you're going to sum it actually. So you will say sum. See, you will perform some kind of operation, average, median, whatever. So right, so we will say sum. Okay, this is the sum of total INR, and you can make it like this. You can also have a title, and the title will be total revenue. Okay, I mean, I'm not good in the coloring, etc., so I will keep this pretty basic. You can make a border color here, and let's say I want to make a blue border, whatever. This is my border color. Okay, and then you just copy paste. So copy paste, and here you can have total quantity. Okay, and you just change. So here you just say sold quantity, and it will show you the total quantity which is sold. Now you want to have some kind of filters at the top, right? See, here is good to have filters because right now it's showing the total revenue and quantity for all the data that I have in my database, right? So what I want to do is add another visualization or filter maybe, right? So this visualization, let's keep it on side. Let's have a filter. This filter will be what? This filter will be your filter. Okay. And the title is year. You see all the years. We have 2 years of data, right? So 2024 and 2025. And just play with these options, folks. This is pretty simple, pretty common sense. Okay. Then after year, you have quarter. Okay. So this will be quarter. So let's add quarter. Okay. Where is my quarter? Here. Okay. That's quarter. So now, and then you will have this at the bottom, right? So let's move this thing here, and here you can have after quarter, you can have month maybe. So let's say you want to visualize data by month, and then you can have what else? After month, you have channel and category, right? So you have channel. So this is channel, category, and so on. Now see, when I change the year to 2024, it is refreshing. So it will now pull the data for 2024. See, this is 2024. Then 2025. So now it's 2025 data. And if you just hit on this cancel button, it will show you all the data. Okay. You can do similar thing by quarter as well. See, here you can use this AI also. You can say top products by total revenue, right? So when you do this, it will use AI to plot that. Okay, so you have top products by total revenue on x-axis, right? So you can give the specific instructions, it will do this, right? So now you can say top 10 products maybe, right? I want only top 10 products. So is this top 10 products? 1, 2, 3, 4, 5, 6. No. So some of the things we might have to change manually, right? So here you can say default number of categories, you want only 10, right? So you are seeing now top 10. So if you hide this thing right here, you'll probably get a better view. And you can also put labels, right? So you can put labels. So see, this one, in 2025, the top product by revenue was Hex Dumbbell, 5.47 billion rupees of sales. You can also add a tooltip on that for sold quantity. And what was the quantity sold? Well, the quantity sold was 531.79. You see that tooltip? Okay. So that way you can display that. You can also add this particular pie chart here. Okay. So we will add, let's say, how do you add pie chart? Okay. So this one is a pie chart. And you can say, okay, it's a pie chart, which is what? Pie chart, which shows revenue share by channel. Okay. Pie chart that shows revenue sales by channel, revenue by channel. Okay. And it will do it. You can do it manually also, but see, so 77.32% is coming from retailer. Then this is from direct acquisition. We have, looks like we have some null values. Maybe we need to take care of it. Anyways, so you get the idea, right? And similarly, you can plot this monthly chart, all of this. Okay, I'm not going to go into too much details of doing this. This will be your exercise, folks. Okay, build an awesome looking dashboard and also write a LinkedIn post and, you know, post the picture of your dashboard, post the summary of the projects that you have done. Something like this. See, this person wrote a nice LinkedIn post saying that, okay, I worked on this and this is the data engineering project and these are the insights. You can attach some simple, maybe PowerPoint, maybe some video presentation, and also just tag us. Okay, so you can, let me show you another post by Aryan. So here, see, this is an amazing post. By the way, Aryan got a job through this post, believe me. He posted this and a recruiter reached out and they interviewed him and they hired him. So you can make this kind of post. You can tag me, Hemanand. You can also tag Databricks and just create this kind of presentation. It will do amazing things, folks. The whole world, LinkedIn will notice you. They will recognize your skills, your sincerity, your communication, right, via this video presentation and so on. All right. So please go ahead, do it, complete the dashboard, make necessary changes, and I wish you all the best. I think that's all we have for this dashboard.
So Peter, how are you doing? Go ahead and share the report. Let me have a look and we shall share it to Bruce later.
Sure, Tony. The report is on my screen. We basically had 3 criteria. The first one was it should be able to provide aggregate analytics for both the companies and it should be reliable. So we tested it. The ETL pipeline is working as expected and we can call it a reliable layer. Second question was on adoption. So I spent about 3 weeks and I was pretty much able to get this project done and the adoption won't be difficult for the team. The third point was about this being a reliable long-term solution. So I'm confident to pitch this as a long-term solution.
That sounds good. I like what I'm seeing. All right, let's send it to Bruce and let's see what he thinks.
I hope you enjoy building this project. Many viewers who are watching this video are students and professionals who can't afford paid versions of softwares and tools. And for that reason, we want to thank Databricks for providing this free edition. Using this free edition, any student or professional can practice data and AI tools for free. Now, if you want to get certified for doing this project, then visit our website. I'm going to provide you a link in the video description below with some instructions. So if you visit that link and follow those instructions, you will be able to get the certificate. If you have any question, there is a comment box below. Thank you.